Welcome to the Numerical Analysis course. In this lecture, we will study Newton's forward interpolation method. Interpolation means a method where we are given some data points. For example, this scenario where we have these data points x1, x2 and x3 and so on, and these corresponding y's, where y is some function of x, and we are given these data points. And we are supposed to find the value of y for some given value of x that is in between some given values of x, for example here. Or we are asked to find the value of y naught for this value of x naught that is between x2 and x3. It can be here, and we are asked to find y naught here. So in short, we are asked to find the value of y for a given value of x that is in between any two given values of x. Right. So we will be given some data points with y is some function of x, and we have to find out the value of y naught between any two given values of y corresponding to the value of x naught that is between any two given values of x. Right. We will be studying Newton's forward interpolation method for equal interval widths. This means the difference of x2 minus x1, for example, would be the same as x3 minus x2, as x4 minus x3 for all values of I, etc. So we will be studying Newton's forward interpolation method for this scenario where we have equal interval widths for the independent data x. Right. So Newton's forward interpolation method, this expression implements the method. It looks a bit complex, but actually it is very simple. Y naught is some f of x naught that is computed using yb, where yb is the value of yi just before y naught. For example, if we are asked to find this x naught here, and if we are given this x naught and we are supposed to find y naught here, yb would be y1. If we are given an x naught here between x2 and x3 and we are supposed to find the corresponding y naught, yb would be the base value y2 in this case. Right. So this is the value of yi just before given y naught, just before y naught. And p is a ratio between x naught minus x base, the value of x naught that we have that we are given, for which we're supposed to find y naught, minus the base value. For example, in this case, that would be x naught minus x2 divided by the interval width, the constant interval width, this one. Right. And once we plug these values in here, that will compute y. But there is one more thing with del y, and how to compute del y. We will try to understand that with the help of an example. So next we are going to solve an example, and we'll see how to find del y. The two other things that we must know to compute y naught is yb and p, that are computed using these two simple formulas. So next we are going to solve an example and see how to compute these three unknowns yb, p and del y, and compute value of y naught. Right. So in an example we are supposed to find, we are given this function y is a function of x that is sine of x. We know sine of x is plotted like this, and we have 0, and this is pi by 2 or 90 degrees, this is pi 180 degrees and so on. This is x, this is f of x, or this is equal to sine of x. Right, so we are given this table x versus f of x, which is equal to y, 0, 30, 60, 90 degrees. And at 0 the value is 0, at 30 the value is 0.5, at 60 it is 0.66, and at 90 degrees it is 1.0 or 1. We already know that from school or college. So we are supposed to find by using Newton's interpolation method, we are supposed to find sine of or f of 45 degrees. This is what we are supposed to find using Newton's interpolation method using this equation. So where is 45? 45 is in between this 30 and 60. So 45 lies somewhere here, and we are supposed to find this one. So 45 is x naught, and the corresponding value of y that we are supposed to compute is y naught. So x naught is given to be 45. X base would be the value of x just before this, that is 30 degrees. Right, so and yb can also be computed. It can straight away be thought of 0.5. Thought of equal to 0.5, the value of y just before the value of y we are supposed to compute. And p can be computed as x naught minus xb, 45 minus 30 degrees divided by xi plus 1 minus xi. You see the difference is 30 for all x's, so that is equal to 30 degrees. So 45 minus 30 is 15 over 30 is 1 by 2. It's also 0.5. So we are supposed to find 0.5 degrees. Right. So we are supposed to find this y naught, but for that there is only one unknown left, that is del y. So let's see how to compute del y. For that we will extend this table by del y, and we have del y, we have del squared y, del cube y. Let's see how do we compute them. Right, so you have to be in between the first y and the second y, y1 and y2, and you need to compute a difference. 0.5 minus 0 is 0.5. Then you have to be in between the second and the third entry for y, and you compute the difference. 0.866 minus 0.5 is 0.366. Then you have to be in between the third and the fourth entry and compute the difference. 1 minus 0.866 is 0.134. Right, the next column is del squared y, and you have to be in between these two, and you compute the difference. 0.366 minus 0.5 is minus 1.34, and you compute the difference between 0.134 minus 0.366 is minus 2.32. And of course the next is del cube y, and you have to be in between these two. Minus 2.32 minus into minus 1.3, that becomes plus. So minus 2.32 plus 1.34 is minus 0.098. Right, so we need to extend this to del cube of y. Right, so the next is we are going to put everything in this formula, and then we will be done. yb, the base value for y is 0.5. Let me use the black pen. 0.5 plus p is 0.5 times del y. Del y is, if we are here at xb, we will be we will be working with this diagonal. We have multiple values for del y and del squared y, so which value we are going to assume is this one. Starting from 30 degrees, our base point will reach to the value that corresponds to 30 degrees, and then we'll be working along a diagonal line. So these are our del y's, del y, del squared y, del squared y, del cube y, right? So P del y, so this is y 0.5, del y is 0.366 plus P, that is 0.5 times 0.5 minus 1 minus 0.5 divided by 2 factorial del squared y along this diagonal line is minus 2.32 plus we don't have del cube y. In this case we don't have del cube y, and now we are going to solve it, and once we solve it, it becomes 0.5 plus 0.183 plus 0.029. This is also plus because 0.5 minus 1 would be minus 0.5. So that is minus 0.5 times minus 2.3, it becomes positive. So all three terms are positive, and the value that we compute is 0.712. That is very close to the value of sine 45. We know the value of sine 45. We studied that in school. That is 1 over square root of 2 or 0.707. You see the value is very close to it, 0.712. So using this interpolation method, we have computed the value of sine 45 very close to a value. We have computed a value that is very close to the exact value of sine 45. So one other thing that we can do is, in order to better understand this method, find f of 10 degrees. Right, so f of 10 degrees, to compute f of 10 degrees, this will be the starting point, and 10 would be somewhere between 0 and 30. So x naught is 10, x base is not 30 but it is 0, yb isn't 0.5 because the corresponding y is for the base is 0, and p is 45, it's not 45, x naught is 10 minus 0 over 30 degrees, it's 1 over 3 or 0.33, it's 1 over 3. So, and del y is the last thing, del y is, you go here and you compute, and you go along the diagonal, you go straight, first you go straight to the value of y, and then you move diagonally along these numbers, right? So that would be y base is 0 plus p 1 by 3 times the corresponding del y is 0.5 plus p 1 over 3 times 1 over 3 minus 1 over 2 factorial times del squared y is minus 1.34 plus 1 by 3 minus 1, 1 by 3 minus 2 over 3 factorial, and del q y is minus 0.098. Right, so in this case we have 4 terms, and once we solve all these terms, you reach to a value 0.18. And we know that using any calculator, we can find the value of sine of 10, that is 0.17. So using this interpolation method, we reach to a value very close to the actual value. Right, that's all for this lecture. Thank you.